All right, so we're continuing with scenario 2. We've already done the conditions and we've already defined it, and we made sure that we defined it as women minus men. I'm going to restate that part. We've input our data in L1 and L2, and it says create a 99% confidence interval for the above scenario. Interpret the meaning of the confidence level. Based on the confidence interval, can one conclude that women are charged more than men for the same car model? So let's talk about a couple things we're going to need. We're going to need our degrees of freedom, which in this case is 8 minus 1, which is 7. We're also going to need our X bar, and I can get that a variety of ways, but stat calc, one variable stats. All my data was in L1 and L2. My differences were in L3, so I'm going to pull it from L3. And if you want to see how to do that, that's in the previous video. So X bar is 585, and the standard deviation is 530.713. Okay, so I'm going to write down my confidence interval formula because everything else I've done in the previous video. So X bar D plus or minus T star SD divided by square root of N. So in this case, 585 plus or minus. I'll come back and do T star in a moment, so I'm going to leave a blank for T star. My standard deviation is 530.7138 divided by the square root of 8. Probably don't need to say this. Make sure you put in here and not the degrees of freedom. This is going to be always the sample size. Always do that. So I need to calculate T star. So second vars, inverse T, parentheses 1 minus, my confidence level was 99, so 1 minus 0.99 divided by 2. Degrees of freedom in this case are 8 minus 1, or I could have just typed in 7. And I end up getting a T star of 3.4994. You are, like I said before, you're going to have to know how to calculate that, and you're going to have to show your work on that. Otherwise, you're going to lose a fair number of points. Then I go to stat test. This is going to be T interval because I'm going to try to obtain my interval. I actually use data, so data needs to be highlighted. My list is an L3, frequency is 1, and my confidence level is now 0.99. And I end up getting an interval of negative 71.63 all the way to $1,241.60. Now, what that means is a plausible value could be anywhere in this range, which means women may pay $71 less than men on average, or they may pay as much as $1,241 more than men on average. Any value within here is a plausible value. And we're 99% confident that we've captured it, which means we're also 1% confident that we didn't capture it. If we did this an infinite number of times or for all possible samples, 99% of them would capture it within their 99% of them would capture it. The intervals will be different. Every interval will be different for every sample, but 99% of them would capture the true mean difference, and 1% of them would not capture the true mean difference. Please do note that every time we run a sample, it's going to be different. It's going to shift. All we're saying is we're 99% sure it's in there. We're 1% sure it's not. We don't know where it is. Could be way up here, could be way down here, or it could be right in the middle. So we are 99% confident that the true population mean difference in car price, women minus men, lies within the interval negative 71.63 to 1,241.60. We don't know where it lies within there. We're just 99% sure it's in there. Of course, there's a 1% chance we're wrong too. All right. In repeated sampling, we expect this method to capture the true population mean difference in car price, women minus men, 90% of the time. Finally, can one conclude that women are charged more for the same car model? No. We cannot conclude that women are charged more. Great, that's right. You got no credit. Why? You had a 50% chance of guessing that. You have to justify it. So no, we cannot conclude that women are charged more. Why? Because 0 lies within the interval. Okay, because the null hypothesis lies within the interval, we cannot claim that women are charged more than men. Not at the 99% level. We could at a lower level, but not at a 99% level. All right. First off, wanted to make a correction here. I wrote 90%. This should have been 99%. All right, because it was a 99% confidence interval. And one of the questions is, can I explain what happens to the interval as I change my confidence level? So I think the easiest thing to do on that is we're going to actually do several confidence intervals and see what happens. So we did this one at 99%. So I'm going to shrink this down from 99% to I'm going to decide to be only 90% confident. And let's watch what happens. So I'm going to run the exact same interval, stats test, T interval, number 8. And all I'm going to do is keep everything the same data and everything, but I'm going to change this to 0.90. So I just changed my confidence interval from 90%, from 99% to 90%. And I should write this down on a separate sheet of paper. So give me just one moment. What we initially had is we had a 99% interval. I should probably use black pen. So 99% interval. And that interval was negative 71.63, and it went all the way up to 1,241.60. That's what we had at 90%. We are going to now change this to 90%. So I changed it to 90%, and I run the interval, and now I have 229.51 to 940.49. Well, notice my lower bound went up and my upper bound went down. So this one was wider than this one. This is narrower. So what we can say is, as our confidence level goes up, As we increase our confidence level, our width or our interval width, excuse me, I did that completely wrong. As we increase our confidence level, our width goes up. As we increase, as we go from 90 to 99, our width increases, right? As we increase our confidence level, our width increases. All right, you're good.
Okay, so also that's something I noticed on the quizzes that some students in their conclusion statements about the confidence level would say something along the lines that that women are paying more than men 99% of the time. And that's not what the confidence level interval is saying. It's saying that the true population mean, we're 99% confident that it's in this interval, not a frequency of how often it happens that women pay more than men.
Yeah, so in repeated sampling, it captures it 99% of the time. Doesn't mean men pay less or women pay more. Just we're at 99% of the time, our method captures it. In other words, it's a brag. We are so good that it works this amount of the time. It does what it's supposed to, which is capture something. All right, it captures the truth 99% of the time.